there, and welcome to this episode of Madison's Chemistry. Today we're going to be talking about elementary steps. So the first thing to address is what even is an elementary step. So say we have a reaction mechanism that looks something like A plus B goes to C plus D. That's our final, right? So this is our overall reaction. But let's say that in order to actually make this happen, the individual steps would be, say, one could be A plus, I don't know, let's say E goes to C plus F, and this could be now B plus F goes to D plus E. And so we'll see that if we were to cancel this all out, we would end up with just simply the E's would cancel, right? And the F's would cancel. So we'll end up with what we started with here. So that would be A plus B goes to C plus D. So this overall thing here is called the reaction mechanism. So our reaction mechanism is going to be the steps that make up the overall reaction. That's going to be these two steps make up the reaction mechanism. But then if we just look at step 1 alone, that's an elementary step. Elementary step. And then same with just step 2 alone, that's another elementary step. Okay. So now we know that what an elementary step is. Let's figure out how we could actually determine the rate law expression if we're just given our elementary steps. So if we're given our elementary steps, let's just rewrite what we already have. And B plus F goes to form D plus E. We would need to know something about the overall rate. So maybe it's like one's faster, one's slower. So let's designate that. So let's say that the second one's actually our slow step, and the first one is our fast step. So only for elementary steps, we can look at the coefficient of reactants in the slow step. Oh, let's move this all down. In the slow step to determine the reaction order or the rate law expression. Okay, so this concept is really important because if you remember in the last video, I was talking about how you can never just look at the coefficients and assume what the rate law expression is going to look like, right? So if we were just given, say, A plus B goes to C plus D, and let's say it's a 2, we couldn't just say that rate equals A squared plus B, right? That's a no. But if this was an elementary step, and say we knew this was the slow step, then this would be okay. Okay, so that might be a little bit confusing, but I'm hoping that we can build upon this and make more sense. So if we were to write out the rate law expression for this, we would say rate equals K times, so we're going to only be looking at this slow step because it's a rate determining step. It's kind of like the limiting reactant, if you remember that from Gen Chem 1. The rate is going to depend on the thing that's slower, right? Make sense? So we'll say that the rate is going to be equal to K times B times F. So actually this wouldn't be correct because we'll see that F is an intermediate, but we're going to take the next video to go over the fact that what an intermediate is and B, how to write a rate law expression like this if we had an intermediate. So ignore the fact that this is technically an intermediate. Just understand that this is how we would write our rate law expression. And I can change this to E or something, and now it's okay. Yeah, so this would be the rate law expression, and we can determine this because we're given our elementary steps. So just remember that only for elementary steps can we actually look at the coefficients in only the slow step to determine the reaction rate law expression. So yeah, I hope this video helped. If you're a little bit confused, we're going to be expanding on these materials in later videos, and I'll be posting some additional practice problems. So if you like this video and you want to find out when more are going to be posted, it'd be awesome if you could subscribe to my channel. And if you like this one, go ahead and give it a like. So thank you so much for watching.